STAAD.Pro is a finite element-based structural engineering software product for 3D model generation, analysis, and multi-material design. Over the past year, STAAD.Pro Connect Edition was released. This version of STAAD.Pro represents a significant update to the product, complete with a new graphical user interface, physical modeler workflow, and a faster solver. Over the next series of videos, we are going to introduce you to the new STAAD.Pro Physical Modeler, and we're going to show you how to introduce this area of the program into your workflow. Let's first start by discussing the physical modeler that's now available in STAAD.Pro Connect Edition, and we're going to talk a little bit about what needs to be done in a physical modeler versus what needs to be done in the analytical modeler to complete your overall workflow and to complete your analysis and design. Now, the physical workflow will be used to model your structure in the STAAD.Pro Physical Modeler using physical members. The physical modeler is used to draw structural elements as they are physically constructed. The program will then decompose this into an analytical model, which is passed to the STAAD.Pro Analysis and Design engine when you run your model. If you're planning on using the STAAD.Pro Physical Modeler in your workflow, it's important to know what tasks will get accomplished in the STAAD.Pro Physical Modeler versus the Analytical Modeler. In the Physical Modeler, you're going to create your model geometry, which includes your nodes, members, and plates, which will be called surfaces in the Physical Modeler. You're going to assign all of your properties, your materials, your supports, and specifications in the Physical Modeler. Now, you may find some of the properties are easier to assign actually in the physical modeler than they were traditionally able to be assigned through the analytical modeler. Lastly, you're going to create your basic loads in the physical modeler. This will include all of your basic primary load cases along with your load items, including the self-weight of your structure. After you create all of your model information in the physical modeler, you're going to move back over to the STAAD.Pro Analytical Modeler. The analytical model is a finite element model of the structure, which is typically processed directly by the analysis and design engine. There are several tasks that you're still going to need to add to your model in the analytical modeler before performing an analysis design, even if you're using the physical modeler in your workflow. These will include such items such as adding code loads to your structure, including wind or seismic through the load definitions area. You're still going to need to generate your load combinations in the analytical modeler. You're going to invoke your analysis commands and specify all of your design parameters and commands. Lastly, you're going to perform your analysis and design in the analytical modeler. Now, in a later video in this series, we're going to show you how to incorporate your design results into your physical modeler, whether you're doing a simple code check of your steel structure or if you're also performing an optimization through the select command. So new in STAAD.Pro Connect Edition, we have two different workflows available. We have our analytical modeler and our physical modeler. Now, the analytical modeling workflow is the same as your traditional way of modeling things in STAAD.Pro V8i. You're going to use the analytical modeler to model your structure using analytical elements. The analytical model is a finite element model of the structure, which is typically processed directly by the analysis and the design engine. New in STAAD.Pro Connect Edition, we also have the physical modeling workflow. This will be used to model your structure in the STAAD.Pro Physical Modeler using physical members. Now, the physical model is used to draw structural elements as they are physically constructed. The program will then decompose these into an analytical model, which is then passed to STAAD.Pro Analysis and Design engine when you run your model. Now, I've already taken the liberty of starting a model in the physical modeler. I'm going to show you some of the tools that we have available there for modeling your system. I'm going to show you what a physical model looks like. We're going to talk about some key characteristics and a few of the things that might be a little bit easier to do over the physical modeler that maybe were a little bit more challenging or time consuming in the analytical modeler. So what I'm going to do is I'm going to go ahead and open up a model I've already created. Now you can see when you start STAAD.Pro and Connect Edition, you're going to have to select which type of model you're going to open. We do separate these in categories now, and what you're going to have to do is you're going to have to select what type of model you're going to be creating at the start of your modeling process. So you're either going to say, I want to create an analytical model or a physical model. And then from there, you would either go to the analytical tab or the physical tab to open up those types of models. I'm going to go ahead and open up a physical model, and I'm going to open up this one that I created earlier. Now, upon entering STAAD.Pro, when you have a physical model, you're going to be asked, would you like to go directly to the physical modeling interface? We'll go ahead and start there. And now we've entered the STAAD.Pro Physical Modeling interface. What we're going to see is that the program is set up fairly similarly to the STAAD.Pro Connect Edition interface. We do have a ribbon along the top of the screen. You can use this to both view model geometry and to create your model geometry. And we also have a data area over at the right-hand side. What we're going to do is we're going to navigate through this data area to specify certain types of objects in the physical modeler. So you can see here we have this separated into categories of nodes. We start with our coordinates, and then we can move on to properties that you can assign to nodes such as supports or rigid diaphragms. We're going to move up to the Members tab, and again, we're going to start by modeling our members, and then we're going to move over to assigning properties, materials, and specifications. And then we can also model surfaces. Now, surfaces, when they're sent over to the STAAD.Pro analytical model, will be decomposed into finite elements or plate elements once they get over there. Lastly, we can also model loads over in this area. Now, what I have here is I have a simple physical model that I've created. Now, in previous generations of STAAD, as well as many other structural analysis pieces of software, modeling of your structure begins most commonly by creating nodes, and then your nodes are connected to linear members. Now, the way we model linear members in STAAD.Pro analytical modeling mode is all of your members must be broken at nodal locations to ensure proper force transfer and to ensure a proper finite element analysis. As you can see in the physical modeler, I've created members that are spanning exactly as they would in the field when you construct them. So this is a much more logical sequence of operations for building a model. You can see here I have a girder, and my girder, when it's built in the field, will be running from column to column. It's not segmented at the intermediate beam locations, although the program is going to know once it builds its analytical model from this that there is connection between these two locations because the node lies along this girder. So what we're going to do in the STAAD.Pro physical modeler is we're going to create all of our model geometry. Now we have a lot of similar tools over in this area of the program that you would in your main STAAD.Pro analytical modeler. To access any of your modeling tools, you can use any of these tools up here, such as your create member tool. You can go ahead and click on that, and you can create any member you want just by clicking on two nodes, and then you're going to click off the tool. To gain access to some additional modeling tools, you can highlight a member in the physical modeler, and then you're going to notice a new member tab is going to become available. And here we have different tools for assigning properties, but we can also merge members, segment members, and create additional type of members using ones that have already been created. In addition to that, one of the other differences is that we don't have a cursor for each individual type of entity. Your cursor is basically acts as the geometry cursor, so anything you highlight can be highlighted at the same time. You can see here now I have a node selected. I can go to Nodal Tools, and you can see I actually have some additional modeling tools available here. In addition to that, you can also create your surfaces. Now again, I don't need to create a finite element mesh over in the physical modeler. I can just create a surface anywhere it exists, and then it's going to go ahead and draw it for me. When I send this model back over to STAAD.Pro, it's going to be able to mesh that area for me. So we've gone ahead and talked about some of the modeling rules. And again, I can highlight my surface. You can see I have my surface tool available here, which brings up some other tools as well. So I'm going to go ahead and model all of my structural components here. I'm going to draw members and surfaces, also nodes in this particular area. In addition to that, I'm also going to assign properties to the members and the surfaces in my model. And what I would normally do for my workflow is kind of work from the left-hand side of the data area back over to the right. So you can see for most of my model, I've already assigned a section size. For the new one I just created, I didn't yet. So I'm going to go to the Sections and Materials area. And you can see here the Member tab is available since I already have this member selected. And I can just simply assign a section to that member. I have the same type of section database that I would have in the analytical modeling mode. So I can select a wide flange section, for example, and let's go with this one. And I can assign a material to it as well. So we'll go with A992. I can do the same type of information for surfaces. I'll go ahead and highlight my surfaces area. I'm going to select my surface, and you can see I can assign a material and a thickness. Okay. Now, after you've created your model geometry, you are going to go ahead and assign properties and also any types of specifications that you want to over in this area of the program. For me, what I'm going to do is I'm going to go to this members area, and then you can see here I can assign rigid end offsets, hinges, linear supports, and also story numbering. One of the things I'm going to take a look at in this area of the program is I'm going to take a look at a couple of the properties that might be a little bit easier to assign over in this area of the program versus the analytical modeling area. So what I'm going to do is I'm going to select all of my floor girders and floor beams. Now, since we are able to model physical members instead of individual analytical members, one of the things that I think is a little bit easier to assign are your member end fixity. Typically, for example, if I had a girder that was spanning from column to column, what it would do in the analytical modeler is it would be segmented at all these different points. And then I'd have to figure out which the starting end of the member was and the ending end of the member and ensure that I assigned the correct hinges to each end of the member if I was expecting a pinned connection between that girder and the column. So what I'm going to do instead is I'm going to do it in the physical modeler. I'm going to come over to the member area and I can just simply say hinge both ends. I don't have to worry about the different segments in the middle because the member is running from column to column. So you can see how easy that was. Another area that's super easy is to take a look at your cross-section positioning. So say, for example, I was designing a small building here, and I have some type of slab system sitting on top of this beam girder system. Now, my girders and my beams are of different height. And I want to make sure that the top flange of all of my members are completely matching with each other. So what I'm going to want to do is I'm going to want to, when you model your members in the analytical model, of course, the line that you see on your screen is the geometric center or the centroid of the member. And what I want to do is I want to change that cross-section positioning to be that line to be the top of the member. And if I had to do that in the analytical modeler, I'd have to figure out the depth of each member and figure out how much I wanted to offset each end of it. Well, here I can use the cross-section positioning icon, and here I can say instead I want to go to top center. It's going to automatically calculate that for all of the members, change it to top center. And if I wanted to take a look at a rendering, there it is. I can take a look and see what that looks like. And now you can see, maybe over on this back side, maybe a little bit easier to see. You can see here how the tops are now flush with each other. Might make it just a little bit easier and simplify your modeling process. So we're going to draw our members over here. We're going to assign properties, including section properties and material properties, and any type of specifications. Specifications could include things like your member offsets, rigid end offsets. It could include axial restrictions such as tension only or compression only members. You can also assign the truss specification over here. And finally, you can assign simple primary loads over here. So if I go to the last area over here, I'm going to find my loads area. You can see we call them load groups over here, but basically what this is going to correspond to is a reference load case. We'll go ahead and see how that's going to come over to STAAD.Pro in a moment. But basically, you're going to create a load group. You're going to make sure you set this type appropriately. So you can see here the different types of loads. I've gone ahead and I've assigned self-weight to the dead load group. I've also assigned some line loads in here as well. If I take a look at basically the member and surface area, I can see the types of loads that I'm able to assign over here. So you can do like concentrated member loads or moments, also distributed member loads and moments. If I take a look at the surface area, again, I can see the types of loads that can be assigned over here. What you're not going to see in the physical modeler is you're not going to see those code loads that you can generate in the STAAD.Pro Analytical Modeler. So I can create simple static load cases over here. If I need to use load definitions, those still need to be done in the STAAD.Pro Analytical Modeler. So for this model, I'm going to go ahead and assume that I've already kind of created the model the way I want to. And now what I'm going to do is I'm going to send it over to STAAD.Pro. The first thing I'm going to do is I'm going to go to this File tab area and select the options. And here, first of all, this is a good way to go to change your units. But what I'm going to do is I'm going to go to the Analysis Model tab. This will give you information and control over how the analytical model is created. In particular, you can also take a look at the mesh type that is going to be created, and this is where it's going to tell the model to go ahead and segment your members when it goes over to the analytical modeler. So you may want to go ahead and review that information before sending this over. Once you're ready to create your analytical model, we're going to go ahead and click Return to Analytical Modeling Mode. And basically what this process is going to do is it's going to send this model over to the STAAD.Pro Analytical Modeler, and it's basically going to build your input file for you. Now this might take a minute or two depending upon the complexity of your model. And then we're going to go over to STAAD.Pro. And I want you to go ahead and take a look to see what you're going to get. Now you can see when we came over here, a lot of the information, of course, that we created has been provided in this model. You can see that our wall that we created has been meshed for us, so that made it fairly easy for us. You can see properties and specifications have already been assigned. Now, what you're going to notice is a lot of these options here are grayed out. That's because this model is officially a physical model, and they're going to want you to change things like section sizes and stuff like that in the physical model. So the workflow for an analytical and physical model is you're going to maybe have to go back and forth between the two modes because you're going to maintain that link between these two types of files. To go back and forth, we're going to just use our workflow panel over at the left-hand side of our screen to go from analytical model to physical model. I'm also going to show you some of the information that came over. So we see all the section sizes that were assigned. That was all done successfully. We can go over to the material areas. Every material that we created over in, or that we assigned in the physical modeler came over. You can see I have A992 and A36 steel. We can go to the specifications. You can see I have some offsets, some member end fixity assigned. My supports came over. And then finally, we're going to go over to our loading area. And you can see basically how our loads come in. Oh, you know what? I forgot to put the live load in there. But you can basically see how our loads are going to come in. So the load groups you create over in the physical modeling mode are going to come in as reference load cases. They are assigned to a particular load category. So you can see dead load here. That's assigned. Oh, I can't modify it, but it's assigned as a dead load over here. So what we're going to do once we get to this point is we still need to complete our model. So we did almost everything we need to over in the physical modeler. We still need to add a few steps to it. So what are the steps we need to add? Well, if we have any loads such as wind load or snow load, not snow load, seismic load, seismic definition, that we need to add to our model using a definition, we're going to do that over here. And then we're going to create those load cases to add those loadings to the model. We're going to generate our load combinations, and then we're going to add our analysis and design commands. So that's all still done in the analytical modeler. Now, as I mentioned a few moments ago, you're not going to want to change things that you created in the analytical modeler, in the physical modeler over in the analytical modeler. And if we wanted to take a look at the input file that the Physical Modeler created for us, we're going to see basically it's going to begin with this start line says do not edit, and everything within that area is in gray. So this area you can see here, I can just type on my keyboard. Well, you can't see me doing that, but typing on my keyboard, it's not going to let me edit anything here because that's part of the physical model information. It wants to maintain the integrity of that model.